Hello and welcome. Today's lecture, I mean to say 6th week second lecture, that is the 27th one. We are going to discuss on the mitigation, and in that today we are going to discuss on agriculture, forestry and other land uses. In abbreviation it is called as AFOLU, AFOLU, agriculture, forest and other land uses. So, through this the concept is if we manage the ecosystem, then how much of the carbon or how much of the emission we manage. So, that means it is dominantly depending on our activities. Through this we are going to talk about agriculture, forestry and other land uses, and we will also see what are the various projections and how it has happened. And then we will also talk about these three sectors in individual, in terms of agriculture, in terms of forest and in terms of various other land uses. We will also see what are the different barriers and benefits and what are the different mitigation and development pathways. Let us talk about this particular interaction. Friends, we understand there is an interaction between the land management, the products it offers in terms of food and fiber, and the interaction between land and atmosphere. If we look at this diagram, on the top or the upper side you have atmosphere, and at the bottom you have the soil, peat and carbon pool, that means our soil sphere or photosphere, and then in between we are talking about the biosphere, where lot of interactions happens in terms of emission and carbon emission. On left hand side of this we are talking about photosynthesis. All of us know photosynthesis is the process by which the plants they withdraw the carbon dioxide from the atmosphere in presence of light or in presence of sunlight, and by utilizing the water which is withdrawn again from the soil. And through this process, as I just mentioned, the plants they sequester carbon dioxide, and this carbon dioxide which is sequestered by the plants, it contributes towards various activities including the respiration. So, respiration is just the opposite process. It releases carbon dioxide from the plant material or animal material back to the atmosphere. So, during the process of photosynthesis, the plants, the autotrophs, they withdraw carbon dioxide, or we say they fix the carbon dioxide, and by the process of respiration again part of that is again going back to the atmosphere, and we put it under auto and heterotrophic respiration. As far as auto is concerned, it is with or within the plant system, and as far as the heter is concerned, we are including the animals and other activities that releases the CO2 through their activities. So, the animals as a depiction, they also do release carbon dioxide by the process of respiration. And as far as the whole system is concerned, when we go for deforestation or logging, the litter fall, that means when the leaf ages and the chlorophyll turns into yellow, xanthophyll, and finally it falls, or abscission, leaves abscission happens, it falls down and gets deposited on the what do you say, soil floor or the floor. So, finally it decomposes, and whatever carbon is there in the litter is again getting deposited in the soil or the upper soil. So, the soil is getting charged with respect to carbon or carbon dioxide. Then with respect to carbon. Then coming to the right hand side, through various processes, industrial processes and other processes, we release lot of carbon dioxide, including other greenhouse gases. So, this is where we need to manage in terms of less release of carbon dioxide and other greenhouse gases to the atmosphere. So, that falls under the broader framework of agriculture, forest, because these are the vegetation activities we do, we modify, and the other land uses. So, other land uses, when we convert it, wetland is converted to agricultural land, cropland is converted to how do you say, industry or a kind of urban area. So, thereby we used to do a lot of alteration in terms of the land uses. Then it has repercussions as far as the carbon dioxide and greenhouse gases release is concerned. So, this is what we are going to see, that if we manage it properly, then probably from this sector, from this AFOLU sector, we are getting a lot in terms of mitigating the climate change impacts. So, the salient features are the important points we will discuss one by one. The first one is, if we manage, so AFOLU sector, it encompasses managed ecosystem. It talks about the ecosystem management, and it offers significant opportunities while delivering food, wood and other renewable sources. So, it delivers food, wood and other renewable sources as well as biodiversity conservation. This is what is the basic services we receive from the vegetation and vegetation system. But if we manage it properly, then perhaps in addition to these basic services, we will get what you say, the services as far as the carbon, as far as the climate change benefit is concerned. Second, this AFOLU, or we say the managed land sector. So, if we manage them well. So, these AFOLU are the managed land sector. On average, they account for about 13 to 21% of the total global anthropogenic greenhouse gas emission, which has accounted during the period of 2010 to 2019, or the last or the past decade or the second decade of this century. So, if we manage this well, then perhaps this thing, what you say, management or conservation as far as this is concerned, it will be within 13 to 21%. So, that means if we manage this well, manage the AFOLU sector well, then our emission, particularly from the anthropogenic sector, will be accounted for up to 13 to 21%. At the same time, the natural terrestrial ecosystems were a carbon sink. Earlier, it has been a carbon. It means earlier, or it is a carbon sink, our natural terrestrial system, and almost it absorbs 1/3 of the anthropogenic CO2 emissions. So, 1/3 means you say the 33%. So, it has, if we manage it properly, then now if it is contributing to 13 to 21%, it has potential to contribute to 1/3, that means up to 33%. So, here we have an opportunity to manage it well, thereby contributing towards towards the climate change mitigation. So, AFOLU carbon dioxide emissions fluxes are mainly driven by land use change in terms and account for half of total net AFOLU emission. So, it contributes to that, and then the rate of deforestation. If the means, it has generally seen that the rate of deforestation is declining, while the global tree cover and also which we measure with respect to the growing stock, they are increasing. So, it is a good news, because if the deforestation is decreased and the global growing stock level is increasing, then it is a good news. That means we are sequestering more carbon dioxide, we are withdrawing, the vegetation is withdrawing more of the atmospheric carbon dioxide. The AFOLU sector offers significant near term mitigation potential at relatively low cost, but cannot compensate for delayed emission reductions in other sectors. So, it has a good potential as far as the significant potential at a very, very low cost. That means, it is the cheapest solution. We don't need to invest, we just need a plant, or we just need to plant this crop or the trees, and it is done. So, it is the cheapest at a very low cost, but the caution is it cannot compensate for delayed emission reduction. So, we need to act fast or delayed emission reduction from other sectors also. So, between 2020 to 2050, so we are now at 2026. So, between 2020 to 2050, mitigation measures in forest and other natural ecosystems provide large share of economic up to 100 tons of carbon dioxide equivalent USD. So, there is a large share as far as the economy is considered if we can mitigate through this AFOLU or the land management sector, followed by agriculture and demand side measures. The economic and potential feasibility of implementing AFOLU mitigation measures is hampered by persistent barriers. So, the barriers we are going to discuss, always there will be some kind of barriers, and we need to discuss and come over of all those barriers. So, assisting countries to overcome the barriers will help to achieve. So, if we help the countries to overcome these barriers, then perhaps the mitigation can be very well achieved and also faster or in a faster means or rate. The next point I want to discuss with you is the bioenergy. So, this is by managing in terms of forest and this. Second is bioenergy. So, bio-based energy options as another option of energy usage has a lot of potential as far as the mitigation is concerned, right. So, simple way of planting from agriculture, forest and land use. The second component is using it as bioenergy, right. So, the range of recent estimates for the technical bioenergy potential when constrained by food security and environmental considerations of 5 to 50 or 50 to 250 joules or joule equivalent per year by 2050 for residues and dedicated biomass production systems respectively. So, these kind of estimates to the as you say by 2050, it is very much fall within the estimated range. So, if we can what you say synthesize, or if we can derive lot of bioenergy from this sector, then we are also addressing towards the energy requirement sector, thereby contributing to the climate change mitigation efforts. Then the deployment of all land based mitigation measures can provide multiple co-benefits, but there are also risks and trade-offs. So, such risks can best be managed if AFOLU mitigation is pursued in response to needs and perspectives of multiple stakeholders to achieve the outcomes that maximize synergies while limiting trade-offs. AFOLU measures have been well understood for decades, but deployment remains slow. The second is concerted, rapid, sustained efforts by all stakeholders, especially from policymakers and investors to landowners and managers, is a prerequisite to achieve high levels of mitigation in this sector. So, realizing the mitigation potential of the AFOLU sector depends strongly on the policies that directly addresses emissions and drive the deployment of land based mitigation options consistent with carbon prices in deep mitigation scenarios. So, three things we got very clear as far as the salient features of this is concerned. One is this agriculture, forestry, land use sector. If we manage this, that means if we properly manage our land, then we can go up to 33%, up to 33%, realizing the potential of up to 33% in terms of mitigating mitigating the climate change, the share of the climate change. Second is the bioenergy, and third, in terms of the barriers, we need to help the countries which are suffering in terms of the barriers. So, to overcome the barriers, we need to come out of the political willness, the investment potential and the economic factors. So, policy, investment, governance and economy are the 2-3 barriers that needs to be overcome so as to realize the potential of AFOLU to the maximum extent. So, now let us understand the drivers. There are a lot of drivers. You can see on the left hand side of this, where it is less deforestation, not consistent, and the more deforestation kind of thing are mentioned as far as the various drivers associated with deforestation. So, law enforcement. So, if law enforcement is good, then less of deforestation, very high, very highly potential, highly efficient. Protected areas. The protected areas, that means less deforestation, payments less deforestation, higher elevation and presence of indigenous people, less deforestation, steeper slope, less deforestation. So, if we practice this, continue to practice this, then there will be less deforestation. On the other side, higher agricultural price, rural income support, nearer to agriculture, greater population, nearer to urban area, nearer to roads, all these they affect negatively. That means there will be more of the deforestation. So, these are the major drivers and their contribution towards deforestation. So, understanding them and managing them well is the key to achieve the AFOLU targets in terms of mitigation potential as far as the climate change is concerned. So, coming to the mitigation, AFOLU mitigation or land based climate change mitigation are a variety of land management or demand management practices that reduce greenhouse gases or enhance the carbon sequestration within the land system. That means the forest land, the wetlands, the grasslands, the croplands, the pasture land. So, various formations of land system, it is very useful and effective in terms of the reducing the greenhouse gas emission and thereby contributing towards the mitigation. If implemented with benefits to human well-being and biodiversity, the land based mitigation measures are often referred to as NBS, nature based solution. So, if you can do it well, then perhaps this can be designated as, or this is often referred to as a nature based solution, because this is the solution which is more suitable to our 100% suitable to the nature. It is in parallel to the nature's choice. So, we put it under nature based solution or natural climate solutions. So, the type of mitigation potential estimates in recent literature include the 4 types. First is technical, economic, sustainable and feasible. As far as the technical is concerned, we have biophysical potential or the amount possible with current technologies available in terms of the technical potential. So, this is the first type of mitigation potential that is available as far as the recent literature is concerned. The second is the economic. So, economic potential do often constrained means by costs. So, usually a given carbon price helps. The sustainable, so constrained by environmental safeguards and are the natural resources, for example, limiting the natural forest conversion. And the fourth is feasibility. Feasibility is constrained by environmental, socio-cultural and or the institutional barriers. So, technical, economic, sustainable and feasible, these are the 4 types of mitigation potential that have been given by the recent literatures. Let us see or have a look at the different mitigation options, though we have been continuing with this discussion only. Though as I mentioned agriculture. So from agriculture sector we do a lot of carbon sequestration, because as the crop grows photosynthesis happens and faster CO2 withdrawal from atmosphere happens. So soil carbon management in croplands and grasslands, agroforestry and also the biochar. So all this contributes to carbon sequestration as far as the agriculture sector is concerned. Then reduced methane and nitrous oxide emissions. This improve enteric fermentation, manure management, nutrient management and rice cultivation. So as far as the agriculture sector is concerned, for other greenhouse gases, we know in terms of the WMG or well mixed greenhouse gases, next to carbon dioxide, methane and nitrous oxide comes. So if we improve the fermentation, the management of manure in agricultural sector, the management of nutrients and also the cultivation pattern, if we avoid wet cultivation, that means we are reducing the methane emission. So if carefully we manage this sector, then also we can reduce lot of other greenhouse gases, that means methane and the nitrous oxide emission, which as you know, the GWP, the global warming potential is very high than in comparison to the carbon dioxide. Forest and other ecosystem in terms of totality. So forest and other ecosystem protect in terms of, let us say, reduction in deforestation, loss and degradation of the peatlands, the management of the coastal wetlands and the grasslands, they all protect, so contribute towards the protection of the forest and other ecosystems, and restoration. So if we restore that, so restoration means various means of restoration through afforestation, through reforestation, that means you have harvested and you are going to reforest in the same patch of land, peatland restoration, coastal wetland restoration. So all this contributes towards the restoration activities under forest and other ecosystems. Now coming to management. So if we manage properly, then it contributes towards improvement of forest management and also the management in terms of the fire. So all this contributes to management of fire and other forest and other ecosystems. Another is demand side measures. So as far as the demand is concerned, for let us say shift to sustainable healthy diets, reduce food waste and enhanced and improved use of wood products. For all three means shift to sustainable healthy diets, reduction of food waste, and if we enhance and improve the use of wood products, then perhaps we can directly avoid lot of emissions. So land use effects are in measures above, so that we can avoid lot of emissions from these sectors. Now coming to the energy, or you said the bioenergy. As we discussed, if we manage well, then perhaps the through energy sector we are contributing towards the mitigation towards the climate change. Then bioenergy from residues and the total AFOLU and in terms of the agriculture, forest and ecosystem. So that means the protection, improved management and restoration of forest and other ecosystems such as wetlands, savanna and grasslands have large potential to reduce emissions and also to sequester the carbon, or we say carbon dioxide, to the tune of 3.9 to 13.1 gigatons of carbon dioxide equivalent per year out of close to 60. So that means it has a huge potential. So this sector of AFOLU we need to target actually. Coming to the global mitigation potential for 20 land based measures, it is mentioned here as far as the agriculture and forest is concerned, and they have been mentioned coming to the demand side is there. On this side you have shift to sustainable healthy diets. And let us see with respect to the agriculture sector as far as the emission reduction and carbon sequestration is concerned. It is mentioned here solid soil carbon management in croplands, soil carbon management in agriculture or grasslands, agroforestry, biochar applications, and as far as the reduction emissions is concerned, we have the fermentation, the manure management, crop nutrient management, improved rice management. Similarly, for the forest and other ecosystems, we have the restoration management and protection activities as listed. So, the actions, barriers and the benefits, role of agriculture, mitigation options and the barriers and the challenges. So, they have been mentioned here as far as the role of agriculture, 20 to 25% of the global greenhouse gas emission, major emissions as far as the methane and all this we covered. As far as the barriers are concerned, the socio-economic and institutional barriers to adaptation, trade-offs between productivity, profitability and mitigation, need for supportive policy extension, finance access and risks of emission leakage and unintended impacts as far as the increased nitrous oxide is concerned. So, from this in terms of the co-benefits and the risk are concerned, improvement to soil health, water retention, biodiversity, increase in resilience to climate variability. Look at the policy and implementation. So, integrated mitigation adaptation, food security approaches are needed, use of carbon pricing, subsidies and incentives, and also importance of MRV, that means monitoring, reporting and verification systems are also needed here. So, let us move on to the potential mitigation measurements and associated management practices. Here on the left hand side, I have listed here the farming systems. So, in terms of the farming system, different approaches, agroecology, the conservation agriculture, the integrated production system and also the organic farming. And look at the middle and the right hand side what you say columns, you will get to know that because of these activities we have, it is contributing towards the reduction in emission, and also the extreme right side, these activities contributes towards the sequestration or higher sequestration of carbon or carbon dioxide. So, these two falls under the various management options in offer. So, let us talk about the agroecology. Limited synthesis fertilizer inputs will contribute towards reduction in emission. In parallel, diverse crop rotation and covering the crops, and also crop residues, livestock manure, green manure, mulch, compost inputs to soil and inclusion of agroforestry. This leads to higher carbon sequestration. Let us talk about the last one, that is in terms of the organic farming. No synthetic nitrogen fertilizer inputs will lead to the reduced emission. In parallel, diverse crop rotation will lead to higher or you say more of the carbon sequestration. Reduction in nitrogen loading improves the nitrogen use efficiency or NUE, whereas the crop residues, livestock mitigation and all these things contributes towards the carbon sequestration efforts. And towards the end, what are the milestones in terms of policy development in these AFOLU sectors? Starting from 1992 to the last one, that means most important one is with respect to Paris Agreement happened in 2015. So, you can see 1992 UNFCCC, then you have the Kyoto Protocol 97, 2007 the Bali that is COP 13, and then COP 18 2012, and also the Paris Agreement. So, in that these are the different international agreements. Then the mechanisms have been developed. In last one, that means in Paris Agreement, nationally determined contributions called NDC have evolved, and the in terms of the compliance and voluntary market financing timelines, they have evolved during the 2012 the COP18. So, what happened between 2008 to 2010, the World Bank, CFCPF, Norway and NOAD, Amazon Fund and all these things have come up, Green Climate Fund have emerged. So, these are the various milestones as far as the policy development in this sector. So, what we discussed have been picked from again from this third report or you say the assessment report 3, assessment report 6, and this is the working group 3. So, sixth assessment report and working group 3, and the chapter name has been mentioned there. So, we discussed in detail the contribution or the perspective of contribution from the AFOLU sector as far as mitigating the climate change effort. So, it has a potential to, if it is managed properly, it can contribute towards 33% of what you say mitigation in terms of the climate change as far as this sector is concerned. So, this is with us because we are dealing with managing the land. If we manage it properly, if we do lot of alterations or the required alteration that contributes towards less or you say emission reduction and higher carbon sequestration, then we will do a good job in terms of achieving the targets as far as the mitigation in climate change sector is concerned. Thank you very much.